Hello friends, welcome to my presentation of assignment 3, Future of Technology of Learning. Uh, it's for the INT7213 Emerging Technologies, and I'm Michael Bruno Selvaraj. And let's get started with our presentation. And the agenda for today is I'll be giving an overview of future technology of learning, compare and contrast between the programs and system development life cycles, intersensory brain simulation and manipulation, benefits and risks, conclusion, and remarks with references. And if you consider the overview of the future technology of learning, it's not no brainer that these days we are kind of like getting more sophisticated and involved with online training and online programming. And in today's world, the education is kind of split between the two worlds of classroom learning and online learning. As technology has grown, that the education environment has evolved over the period of time, and these days we have started using video conferences, webinars, and course management systems, knowledge management systems, which have helped us immensely in like learning. And however, I see there are kind of like few gaps in between the actual classroom learning and the online learning. The biggest gap I see personally is the relationship which we have with the professor or the fellow class students is kind of like hard. I think if we can reduce this gap, it would like greatly help us in in the successful having of online learning. And I think in the near future, with the Google Glass and the other stuff which are coming up, I think it might get more user friendly and close to us. And as per Google, it believes that like the machine learning is the next layer of programming. This means that they're trying to come up with an API kind of interface where they would develop this whole training into a podcast or like the video webinars, and they'll save it in a secured server, and like it would be viewed by the other users who are taking the course. And virtual classrooms and virtual reality are going to be a game-changing technology in the years. Yes, of course, we are taking this class through the online collaborate tool, and at times like we're having this kind of sharing sessions, which helps us in moving forward and progressing in terms of the classroom learning. And the some of the ways through which we can improve this kind of education is we can collaborate and integrate socially, and we can make this as a new experience altogether, and this can increase the students motivation, uh, and we can reward on the positive note and the positive simulations, and it creates a new whole world for creative learning. And I have created a knowledge management map. Let's see how it is. And actually, the knowledge management, in terms of knowledge management, the key behind the drivers behind this is like people, technology, process, and strategy. Strategy is the business strategy, and the process which I'm considering here is the business process. And the people who are involved here are the employees and the technology which we are using. Moving on to the people, I think communication is kind of key within the people area and training, and in terms of performance and rewards and recognitions. In terms of training, the key is like we need to reduce the classroom, and we need to provide more online training in terms of moving forward. The reason I say that is if you're considering a profit organization, we need to eradicate uh, most of the classrooms and the infrastructure which are involved in it, and we need to deliver it more online so that the employees aren't like traveling around for the training programs. They're more in the same organization, in the same building, using the same infrastructure where they work, and they can get trained. In terms of technology, I think building knowledge portals through the shared portals internally to the organizations, as we have discussed in the previous discussion boards, where we are using the knowledge management tools in each individual organization and how they are organized hierarchically, is kind of like a key driving factor behind this. Having shared drives, business apps, document management, content management softwares, these are kind of the enterprise wide tools which we can use. And In terms of roles and responsibility, each individual has our own role and responsibility to capture the knowledge and share it with the organization. But most of us, we don't do that, but it's a good habit to actually document and have a set of knowledge base. And moving on to the strategy, I think in terms of financial strategy, it's kind of like a cost reduction strategy where we are kind of like using our own resources to train our own employees. And in terms of revenue generation, I think this can be used as a service, and in terms of sharing like a common knowledge or having a common community of it, it's kind of like helpful. In terms of like ISAC or some organizations like this help in sharing their knowledge in communities, and they attract more membership towards them. And coming back to the presentation, let's quickly discuss about the waterfall and the agile model. I think waterfall and agile model are kind of like growing importance. In nutshell, I would like to describe a waterfall model as it has poor quality, poor visibility, and it's too risky because it's following a traditional approach where like you're analyzing, designing, coding, and testing the software in each phase. And if there is a change in design, you gotta like go back to the phase, and it's kind of like risky. But in terms of agile, it's kind of like more of a traditional approach, which is like boxed into a time frame, shorter terms. And in this, like I mean, the waterfall model and agile model are kind of like complementary to each other. And agile model provides more quality, more visibility, and the risk is reduced because we are getting to feedback early and the testing phase have started already, and we are not like running too behind, or like we're not running too far from the requirements, and the customers are like always happy to make the changes, and like we can impart the changes in the whole process again. So moving forward, I think like DevOps is the upcoming operation, which most of the SDLCs are looking out for, where like we're more defining the scope, using tools, and engaging the stakeholders continuously. That way we are kind of like defining the requirements, and develop during the development phases we are like kind of continuously testing, continuously giving the feedback, and accepting the testing. And then by end-to-end traceability we're kind of like imparting the PMO principles into this. And the ops backlog is where the shared artifacts are present, and like once in a while we can pick the stories, and like we can move forward, and like we can continuously validate, automate, and we have the integrated incident systems which are kind of like helpful in during the maintenance phase. So in a nutshell, DevOps for continuous feedback, quality, and delivery is the motto which most of the organizations looking out for these days. And this is a quick video I have. And let's look into the anatomy of the human brain, jumping into the next topic. I think like human brain is kind of complex structure. It controls every aspect of our life, and it weighs about like 3 pounds, and it consumes more than 20% of the everyday's energy which we consume to keep our life ball burning and running. And it has double the size as the humans have evolved. So the complex here brain structure, I have mapped it, and let's see how it is. And brain has a few critical parts. Among that, I would like to emphasize on the limbic system. And and in terms of the anatomy of the brain stem, corpus, hypothalamus, and thalamus are the key regions. And let's look into each one of them. In terms of brainstem, it is a connecting portion from brain to the spinal cord. It holds the pons and the medulla oblongata, and it is helpful and useful, and it regulates the breathing and the heart rate. It regulates the automatic as well as the non-conscious activities. In terms of corpus, it has like two portions of the brain. It's right side and the left side of the brain. And right side of the brain is kind of like more helpful in having creative thoughts, and the left side of the brain is more towards the logical thoughts. In terms of thalamus, thalamus is the portion which sends the emergency information to the lobes, and it kind of like it has the optical lobe which is helpful for viewing things, and has sensory. And in terms of the hypothalamus, it determines the outside functions and the inside functions of the body, and it is connected to the pituitary gland, which is kind of like the master hormone gland which is present in our bodies. And let's get back to the human brain. And brain consists of a neural interface and neural activities, and it has like more than 100 billion neurons which are like kind of like created among them, which are kind of like connected and it has more algorithms in it. And that's the reason brain has come into focus. That like I mean, it's kind of like a supercomputer having in a short form and in a package environment in our skull. And brain kind of is used in, I mean, it controls every aspect of our life, which I have discussed, and it forms an artificial intelligence to design the algorithms. On a rough scale, by 2020, we expect supercomputers will have more than 200 petabytes of data. So if you consider this, like as we are progressing in an era of like where the data is stored and like retrieved and like used at the same time, I think the storage capacity of brain is kind of like immense. And if you compare if we are trying to understand the algorithm functionality of the brain, and then we are trying to implement the same thing in the data storage so that like we use less space and store more information, is kind of like becoming key and research area for this interbrain simulation and manipulation. And some of the potential challenges and risks are, for example, like I mean, these days like experiments are being conducted towards brain simulation and having chips and sensors being embedded into our body. This kind of like things helps in curing few of the diseases and the post-traumatic disorders which our soldiers face these days. As per the Celsius, from 2000 to 2010, more than 3 million soldiers who returned back home, actually among them like 30,000 died because of the post-traumatic disorder, which is kind of like closely connected with the limbic system, which is responsible for the brain to alert during the uh, insecure state. And these days, like the Navy SEALs, like for a batch of like 130 people, only 30 get picked up because they have the better efficiency and better working of the limbic system. It's kind of like funny to say, but like it kind of like helps. If you practice more, we tend to get stronger. That's because our limbic system recognizes the patterns and how we play and what are how to react, and it happens spontaneously. And I think like right now it is so unclear using this memory enhancing devices, which would be good or bad for humans. But one thing is for sure, framing the policies and regulations at the national, state level and international level is going to be a huge challenge for this neural implants. And these might lead to the allergic reaction, since we are using metal particles or some other particles, and how they're going to behave in a longer term. And I think privacy is going to be key aspect here, because we are going to use the chip and read someone's personal and private memories from their mind, which is kind of like scary. But until and unless we have regulated guidelines and protected uh, environment, it's so complicated to protect the privacy, and we need more future studies for this. And what are the I would like to consider take some time and talk about the concluding points. I think brain stimulation and exercises have proven to us that they increase the performance, retrieval, and storage of the information in our brains. And the concept of brain implants has been fiction, but these days the U.S. Defense Advanced Research Project Agency have allowed to connect directly to the computers and the control systems using artificial implants. And the picture here depicts a paralyzed man was walking for the first time ever when his brain was directed towards control using the implants. So I think as neurobiologists are working hard towards getting this conceptual study into a reality, is going to be an interesting aspect in our next future emerging technology. And these are the references which I have used for my presentation. And for any questions or comments, please post it on my discussion board and I'll get back to you in 24 hours. And thanks for watching my presentation.